Okay, so for the textbook, we're kind of like not on the textbook for the exact moment because I need to explain everything that you need to know to write kernel modules to do the project, which I haven't posted yet. I sort of forgot to put this into the calendar. So we'll get back into the textbook next week, and I think, yeah, we're on chapter 3.
So if we're reading chapter 3, I'll be caught up on the text then.
Yeah.
Is the lab up yet?
Lab is up, yes.
Okay.
The next 3 labs are up. And so you can start those anytime.
It's due on Monday, right?
Tuesday. It's due Tuesday.
Tuesday? Okay.
Is it due Tuesday?
You said a week from Tuesday.
Oh yeah, I said about a week or so, last Tuesday. Good point. I never went back and put the due date on the lab, but yeah, that sounds like a good due date. We should go ahead and do that. That sounds good.
Really? No.
Make it all official. Okay, so this is
Should just start calling it the beginning of the next week. Class that
okay,
week.
lab 5, 6, 7. So I need to due dates for these things. Yeah, sounds good. So okay. Okay.
I think today's the 22nd.
Yeah, probably thereabouts. And so next Tuesday would be the 27th. Kind of like the 28th though. 28. Okay, and then I need to calendar, actually I need a calendar -3, which shows November there, and that would be November 4th and then 11th.
The semester's going back quickly.
Yeah, it is. Oh, we did Thanksgiving break before we know it. Actually, I should check this.
And then finals.
We'll have a project due over the Thanksgiving break, won't we?
I don't remember exactly where those things fall. I should check that real quick for you. Okay, we got due dates. Good. Yeah, you asked a good question like, what do we have due over Thanksgiving break? Usually I try not to put anything real dramatic over the break. Sometimes people like to go have Thanksgiving, which is also a good time to catch up on studying and that sort of thing. Yeah, so I got project 3 that'll be due pretty soon. You're already kind of working on it actually with the lab 5, 6, and 7. Because lab 5, 6, and 7, piecing those together gives you, I don't know, today's the last piece, and then you pretty much got project 3 in bits. And so I'll post the actual project description, but it's kernel module writing. And so that'll be due, I guess, the first day of this week, and then project 5 would be the one you can work on over Thanksgiving break if you want to. Project 5 is not nearly as hard. You can see these are all kind of clumped here because 4 and 5 aren't going to take as long as the other ones will. And we're getting a little bit behind on the book here because we haven't done chapter 3 yet, and it's this week here. So we're going to have to make up some time on the book. We'll just go a little bit more quickly, and then I'll ask test questions that are a little bit less in depth. And it'll be fine because you'll know how to create kernel modules.
Wait.
And that'll be a good skill. Yeah.
Which project will you count as a 20% of the?
That's project 3, the
Okay.
kernel module project, because
Okay.
I expect it, for reasons I don't actually know yet, to be twice as hard as the other projects.
I don't like that.
Well, yeah, and it might not be. I don't have any really good reason for it to be. It will certainly have a lot less lines of code than the other projects. And
I do like that.
yeah, so it'll be, short, and it's possible that you just start it and you're done 3 hours later, but it's kernel module development.
That's usually what happens
Something
with
will
me
go on.
sometimes. I usually don't work on it until the last minute, and I just kind of throw it together.
Punch it out.
No, I just wouldn't recommend doing that.
Oh.
Yeah. It's not very fun, it's very stressful.
Oh, okay.
Oh, and what's,
Yeah, usually when I try to do that, I end up missing deadlines.
Do we still get the option to make our file system into a kernel module or not?
At least when it comes to
Yeah.
mobile programming.
Or the keylogger.
Project 3 is worth
Okay,
it.
I'm
Yeah, I think that's a great idea. the wrong computer.
Not my forehead.
Also, just curious, I remember you mentioning at the beginning of the semester that we wouldn't, are we gonna have to use like one of the lab computers in here for writing kernel modules since we can't really do it on, or can we do it on Isoptera?
You can't do it on a software because you can't test the kernel module on a software.
Right, so we'd have to just do it on one of these computers or.
Well, yeah, or just install the same Ubuntu version on some piece of junk you have laying around in the attic or something.
Okay.
Laptop it is. I
uh,
found that the Ubuntu 4.04 does not work well on a laptop. You have to use Ubuntu Make 14.04.
14.04, okay.
And
Yeah.
that will work just fine.
It should be fine. The main thing for, if you just, well, I'm gonna put the file system in there as an option if you want to do that. The file system option is harder, but I'll put it in as an option for the project. If you do that, you don't need a PS2 port. But if you do the other project, the keyboard monitor, then yeah, you'll need a PS2 port because it'll only work on PS2 keyboards. It would be good if it worked on USB keyboards too. Maybe I should offer 10% extra credit on that.
That's
It's
not really file system people then.
Well, maybe they get 10% anyway, because their project's a lot harder.
Is there a way to convert the keyboard output to what you want?
The USB keyboard?
Yeah.
Well, the USB keyboard uses an entirely different system for interrupt handling. And I'll talk about handling interrupts today. So the interrupts, you know, that's the problem here. You got to be able to, instead of reading interrupts for the PS2, you got to read the interrupts for USB, which is more convoluted. Oh, anyway, so here's how interrupt handling works. I think I've got something in here called PIH, and not in that one, but maybe not in that one. Okay. So there we go, keyboard interrupt handler. I got one in MNet. Okay. So this is a keyboard interrupt handler. And so it services keyboard interrupts. And by servicing, it just means when the interrupt happens, this interrupt service routine gets called and is run. And what this one does is look for the scan code that the keyboard produced and check to see if it's the same thing as escape. And apparently there's multiple scan codes for escape. That can certainly happen. And then it returns that we handled the IRQ. Okay, now you can actually have multiple interrupt handlers installed for a single interrupt. And so that's why putting this in doesn't replace the keyboard interrupt handling with this. It just adds a second method. And so that way we can keep pressing keyboard buttons and having things work right. Okay, go ahead and copy this MNet directory. Actually, kind of like a fixed one, because we changed the MNet module all around, didn't we? Yeah, we'll go find it later. So I'm going to go to R4C1. All these computers, well, you guys are upper division. You remember when they used to be in rows. They're still named that way, like row 1 computer or whatever, even though they're around the room. And they got scrambled again when the carpet got changed. So the numbers make 0 sense. But anyway, that one is row 4C computer 1.
Did they ever find our printer?
No.
Who's not sure?
Okay.
I still think someone did it.
So we're set up on here. Let's go ahead and build that keyboard interrupt handler module. If we look at the make file, it's set for simple test. Yeah, we did that a few, like last week. So keyboard interrupt handler, make, and yeah, it builds it. Good. And I hope it built this for the right kernel module version. So it's inserted. .ko. Okay. Actually, I might just go ahead and become root. A lot of times that's easier. So if we look at the kernel, whoa. Module verification failed, signature and or required key missing, tainting kernel. Hey, but it's still in there, that's fine. Okay, so it should be in there. Let's take a look at the source code for this thing real quick. So we got this IRQ handler. I haven't explained how the IRQ handler starts working yet, but it has a print K if we pressed escape. And if we demessage, we don't see that. So I'm going to go push escape on the keyboard. Okay, I'll push it 3 times. See how reliable this thing is. Okay. And so then I want to do demessage over here again. And what we see is nothing at all.
The change is bad apparently.
Huh. It is in fact in there. I used the right keyboard? Yeah, I did. Good. There's 2 keyboards attached to that thing, and if I use the wrong one, it definitely will not work. Okay, let's take a look at that thing again, because I feel like that ought to have worked. And print K, you pressed escape. But I'm wondering if we got some other kind of problem here. We requested IRQ23, which is good. We put an IRQ handler on here, which is good. And that should be like all we need. Wait a minute, IRQ1. This is at IRQ23. This is a problem. Let's go switch it to IRQ1. Okay. Could not remove KIH. Lovely. Okay. Well, we can't put it in here because it's already in. And we can't RM mod it.
Can you RM mod dash F?
Okay. Could not remove device or, yeah. Definitely couldn't remove it. So it's busy handling an interrupt here, interrupt 23 to be specific. And it doesn't seem to be wanting to come out of our kernel very bad. Probably going to have to restart the machine here to get it back out. So there we go. I'll be back up in a minute. Normally this thing does actually work. I think I had set it to 23 for some reason. I don't remember why. And so anyway, see if this works better this time.
I like how enthusiastic that computer is about rebooting. Going down for reboot now.
Yeah. Well, yeah, reboot means the same thing as shutdown -R now. And so it just runs the same thing. If we do shutdown -R now, we'll shut down right away. But if we say like +5, try to sudo it, it'll actually tell us, well, it's going to go down in 5 minutes. And as it happens, we can cancel the shutdown. It's not the same as the init system on Isoptra. I was talking about shutdown the other day with my other class, my Linux class, and we were playing, we tried shutting down Isoptra, but we canceled it. We didn't actually shut it down. And people started writing me like, oh, scared me. It's funny. Okay. Wrong password. There we go. Word. EIH. Okay. There we go. So there we go. We got our little thing there. Let's see. Let's press escape a couple of times. I don't see any particular reason I should need to log in. It's also possible the escape key doesn't work on my keyboard. I never did check that. Well, there it goes. It works. Interesting note. I pressed escape 3 times, I'm pretty sure. And I actually see 4 of these, plus a couple of times when it didn't say you pressed escape. This could happen. The keyboard, so you hold down a letter, obviously it knows that that letter is still down. And so it has the ability to continue repeats there. So maybe I was just a little bit slow on the middle time. And you can see the time is definitively different on each of these. So my guess is I just wasn't careful to push it up. And later, higher up, this sort of thing is handled so that you don't normally see duplicate letters and that kind of stuff. Anyway, yeah, so there we go. Okay, let's see if we can RM mod that. Oh, that's going to get old real fast. Oh, we'll go take a look at the module this thing reboots. Okay. Okay, so IRQ handlers. You guys remember IRQs from like all kinds of stuff, and so, and this one's not fixed yet. So you got IRQs with different numbers, and the keyboard is IRQ number 1, and so that's traditional. This is where your keyboard always was until the rise of USB keyboards, which I guess might have been like 10 years ago now. And so now they tend to run on a USB bus instead. But anyway, so IRQ1 was your keyboard. So this request IRQ function here, this allows us to attach a handler to an interrupt, and we're going to attach IRQ handler, which I think is just right up here. There it is, IRQ handler. That's our function, and so then this IRQF shared. There's more than one way to request one of these things, but we want to share the interrupt with whatever the previous handler was. Probably if we tell it that we're not going to share, it's just going to tell us that we can't have that interrupt in that case. Like something else has it that's not going to be okay with that. But anyway, we can say shared, and that's fine. And then this comment here, test keyboard IRQ handler, it'll appear somewhere in the rest of the kernel stuff. And then give it a pointer to IRQ handler. I don't recall exactly why it needs this second iteration of the same parameter, but it does.
Is it returns?
What's that?
Isn't it returning IRQ handler?
Well, this is giving it a void pointer to return to IRQ handler, basically. So, yeah. Okay, so this returns an IRQ handler type. I don't remember if these things are in the manual on our software or not. I added a bunch of stuff into the man pages. Probably not. Okay. Unfortunately, for a lot of the kernel stuff, this is the manual. 3.16. Okay. So the IRQ handler type, if you want to take a look at what that is, it should be an include and Linux probably. And so from here, grab our IRQ handler type. And we'll see a few different ones here, but we want to see where it's actually defined. And it's probably actually going to be an interrupt.h. Might as well just check that. Okay, IRQ action has an IRQ handler, and let's see, is the use of it. IRQ handler T. Must be type def somewhere. Apparently not. Oh, there, type def. So an IRQ handler type is actually a function type here, where it takes an int and a void parameter. And so that is what an IRQ return type is. But anyway, it's returning one of those things. And the value we return for it, if I pull this thing back up here again. Okay, we're returning IRQ underscore handle. So let's go back in here. So that's our IRQ, if I can spell IRQ right. Feels like that should be easy to spell. Okay, interrupt is handled by this device. IRQ return.h. So IRQ handled like a 1 bit shifted over 0 places. Not sure what sense that makes exactly. But it'll give us a value that apparently indicates that it is in fact handled. So now you know.
Wouldn't that just flip it to 1? If it's a 1 shifted over 0 places,
Yeah.
wouldn't that just flip the bit?
Yeah. Well, I think what they're doing is a 0, like the place for the bit. So like a 0 and then a 1 and then a 2. And the next one would be like a 4 and so on.
Oh, okay.
Like chmod, but with
bits.
0, 1, and 2
Yeah.
instead of 1, 2, and 4.
That makes sense.
Yeah. And I suspect that using the bit shift here, the author must have thought that this was going to be clearer somehow.
0 shifted over 0.
Well, yeah, I got 0,
Yeah.
and then, if you kept doing the bits, I suppose instead of doing this, we were going to do, we were going to have, say, 32 bits. We were going to use the entire integer as flags like this. then this would be pretty clear, because this would be telling us which bit we were on, well, bit -1. And it might be easier than enumerating the powers of 2, especially once the powers of 2 get high. Up until about 128 or so, everybody's totally happy with it, and then after that, they get a little more, you know.
Grouchy.
Yeah. So that would be one reason to do it, and then just kind of keep consistency with other stuff, or I don't know. But anyway, that's just a value. Okay, so we get this scan code from INB. That should be in the manual, even on here. Okay, a lot of definitions here. Sorry. These do port level input and output. So this is how we get stuff off of devices, and yes, I think we've talked about these ones before and mentioned that they're actually inline macros and won't be substituted in without optimization enabled, which can cause problems. And so anyway, this gets stuff out of devices. So over here, oh, I don't mean over there. Oh. We're getting the scan code out of the keyboard. It is number 60. Well, 60 in hex. So I guess that's actually 6 times 16 or 96 decimal, whatever. Anyway, so we're reading what our device has to say. And the keyboard is fairly uncomplicated to read from in this setting. The PS2 keyboard, remember, it's going to be producing an interrupt every time a key is pressed. And so what we need to know is, what was the key that was pressed? And the keyboard will send us a scan code. And the scan codes don't necessarily correlate with ASCII letters or anything that convenient. But anyway, we get an interrupt and we can read a scan code. So one interrupt, one scan code. With a USB keyboard, this would be more complicated because we're reading off the USB bus, and so we got to read from the correct device. And seeing the USB as a polling interface, it may be that our keyboard has had multiple keys pressed since the last poll, and that can be an issue. So it becomes more difficult in that scenario. But here we go. So we got a scan code out of the keyboard, and we just have to check and see what scan code we have. Let's make it a little bit more generic here, so we can answer the question, like, what do keyboards do?
So can you keep that whole thing open for as long as you want, or does it just alternate on-off no matter what?
Which thing?
So for like USB bus.
Oh.
So like, can you keep it open while you're doing something with it, or?
It'll have a frequency it pulls at, and then you get an interrupt with the information from it.
Okay.
And so it's not like open or closed particularly, it's more like,
Okay.
hey, the USB bus has something to say.
So just like every time it pulls it, just feed it the information you want to feed it then, basically?
Well, yeah.
Okay.
I'll read the information off of it.
But like writing to them is the same then? So
Writing to it.
So if you want to send information to it, is that the same process?
No, because it's not going to need. You're not going to need to use an interrupt for that necessarily.
Oh, I guess
It's just not going to make any interrupt for you.
Okay.
So you're going to want to use outB and write to the device.
Oh, okay.
Yeah.
I guess I was thinking about that backwards.
Oh, okay. Yeah.
Interrupt handlers, right?
Yeah, we go the other way. Okay, so let's change this PIH.C and just go ahead and print out scan codes. It'd be sort of cool if it just like printed out as we did it or something, but I don't have a good way to do that. Okay, print them in hex and decimal. Why not? %D, %X.
Yeah, all right, can you do capital X or lowercase?
Lowercase. Okay, so yeah, I should print it out as a dust. Now, it's an unsigned character, but that's probably going to be fine. Okay, maybe it's not. Oh, printf. I meant to do print K. At some level.
What's the difference between the two?
Print K is the kernel equivalent of it.
Oh,
And there is no printf inside the kernel, because there's no terminal that you're using really. It's run inside an interrupt handler here, so there is no user I/O. And so print K just prints stuff into the kernel log. If I remember right, NetBSD may actually call the kernel one printf that runs into their log, but Linux they call it print K. Okay, so there we go. It's in there. I'll go over here and, oh hey, this is an easy way to get a password. I'm going to log in because it says student here, right? Learn, enter. There we go. So, we should be able to get the keyboard, the password. There it is. You know it now. Kind of. Okay.
It's not entirely readable.
So learn here. Learn is 5 letters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And to be fair, I hit enter at the end.
So you have to enter twice, though.
Yeah, it does seem to have registered on here twice now, doesn't
I thought I
it?
heard you hit it twice, actually.
Did I hit it twice? Well, I pressed it and I released it. But I would have thought those have separate scan codes. Oh, anyway. So you can see we got like low number, high number, low number, high number, low, high, low, high, low, high, low, high. Learn.
What?
What? Okay. Key up and key down are going to have a different scan code. Let's go ahead and take a look for keyboard scan codes here. Let's demystify this whole thing. There's a file inside Linux that'll have them too, but this may be more expedient. Okay, so I notice it says escape produces scan code 1. When you press it, escape release provides scan code 81 in hex. So that's what we were looking at originally. Remember, it says scan code is 1 or scan code is 81. So let's take a look at something over here too. Looking at this in hex, our key there, we went from 26 and our next one is A6. So this is sort of similar here. Take a look at the next one, 12 and then 9-2. And this is sort of similar again. And you notice that the offset here is actually the same. Like we went from 2 to A, we went from 1 to 9. In fact, the offset here appears to be 8. And so we keep looking at this pattern, it'll hold up. Because again here, you got E on both of these, you got offset of 8. Offset of 8, same letter, offset 8, same letter, offset 8, same letter. So this is going to be a common theme. The releases are just 80 hex higher than the presses. Okay, so that's mentioned. Let's go ahead and try something else over there. When we do this, so we can tell like from the date code here, we got 619 whatever, and that's all that's in the kernel log. So I'll go ahead and go over here and press enter, kind of quickly, because I don't want to hold it down. And what do we see? We see the 28 and 1, and we see the 156 and the 9C. So the question here is, what was the 250? I'm not really sure. Where's our...
FA came up twice the last time too. That's a 250.
Well, the 250 FA came up twice here, yeah. The 28 156 appears to be press enter, release enter. I'm sort of wondering if I just like hit some other key, like maybe a space bar or something. I don't know. Key scan code 0xFA. We'll find out. That'll be easy enough. Okay, PS2 keyboard, OS Dev Wiki, which sounds like something for people that write operating systems for fun. They ought to know what they're talking about. What was that again? FA? FA. Okay, FA. Set all keys to Typematic auto repeat make release. Scan code set 3 only. Well, there you go. That's the mystery. I did not hit another key. I always learn stuff about this when I do it, because usually I don't actually watch the scan codes to my keyboard while I type. if you ever wanted to learn these things, you could write a kernel module now that it records them. We just did that. And so it'd be a little bit easier if you have it report them in a file or something, and then just have some user process watch that file, and whenever, tail-f-f, and whenever anything adds to it, it can show you your keystroke. So then you probably don't want to use valuable screen space on it, so you'd probably have to get some other device, like a little LCD screen or something, glue it to the front of your computer and wire it up to your parallel port and have it display the codes as you go, and eventually you'll know them all. Okay, but anyway, so that way you'll be ready for the test when I ask you to draw the scan code table. That is the last question.
The entire keyboard.
Well, I'll put a picture of the keyboard on there, and you
You have to write in the scan code.
Oh, these like blanks for ones that don't have any particular key associated with them.
So I'm guessing for the last test, you're gonna allow notes?
Well, I don't know that.
No scan codes.
No sk-
So there's the scan. Okay, so it's got protocol scan codes here, ones that stuff happens.
Oh, FA is also
FA,
acknowledge.
acknowledge from keyboard. That's probably actually it.
Ah.
So my guess is like the numlock status was changed or something on that thing when we logged in, or some kind of repeat rate setting or whatever. That's something repeat rate setting. Numlock's on now. I'm not sure it was on before. So, and maybe that's what happened. I don't know. Acknowledge from keyboard. So maybe you got told to turn this numlock on without B. I don't know. Okay, so we got all these scan codes. Let's take a look at something else here. I'm going to go ahead and turn on caps lock. Okay. Oh, I feel like I hit Shift 2. And then I type learn again. And we'll go take a look at this. It's lengthy fast. Okay. So 615, we're the 978 group here. And so caps lock must have been like the 53 here, I guess. And I don't actually see an up and down for it. But then we got these 250 FA, 250 FAs. And so presumably the keyboard, we push caps lock, and the operating system probably has to tell it something like, okay, you can have caps lock on or something like that, and then it probably acknowledges it. That would be my guess. And we have the same thing here as when we turn numlock on, so that's cool. Okay, so we got 42, that part makes very little sense. N, how do you spell it? Learn backwards. Learn, N-R, Learn. It is 5 letters. 1, 2, 3, 4, 5. That would be learn there. This other stuff right here, not sure where that's coming from exactly, but okay. So I think this 38 to 166, etc. Looking over here, before we had 38, 18, 30, 38, 18, 30, 19, 49, 19, 49. This is notable for the lack of difference with the previous time I typed learn when caps lock was off. So the story here is that the keyboard itself actually, although it has a light to tell you when caps lock's on, and I just turn it off, it doesn't actually send you a different scan code. Sorry. And so the operating system has to keep track of that. Okay, I pushed caps lock again there, and I saw the 58 and a 186. So that way to press and release. So back up here, we saw the 58, and we saw this acknowledgement, and then we saw the 186. I'm wondering if the 42 is just like the user still has their finger on the caps lock button, and I must have pressed it slower. And so the sequence of scan codes here kind of depends. Let's test that theory. Okay, I'll go over here and I'll hold caps lock for a moment and I'll let it up. Okay, so I'm coming over here and I'm typing slowly. Okay. Okay, so caps lock. Yeah, there's all our 58s. Now we know what that's for. So, now caps lock's on again. There's nothing particularly, I don't know, difficult about it. It's just, that's how it works. Oh, here's something else. So I just turned off caps lock. We know what caps lock looks like now. I'm going to push these media buttons. It's got a mail icon a picture of mail. It says 1. Push that. Now it's got a picture of a house. I'll push that. Oh, incidentally, when I pressed the mail button, a rhythm box came up on the screen to play music. And it's got a magnifying glass icon. I'm going to push that too. And something else happened on the screen, but whatever. Okay. A lot of times keyboard manufacturers put these extra buttons on there and they do things. Oh, whoa! Ha! So this System D is not anything related to us. It just happened. This one, unknown key pressed. Ha! Funny.
Oh.
So we found some unknown keys to press.
You can put some unknown keys in your password, and that would, well, no, that would work.
It probably wouldn't work for Windows because it's most likely a Windows key.
I'm not sure it would work for Linux either. I mean, if you hit an unknown key,
It doesn't generate a character, it
Right.
generates an action or an
Yeah,
acronym.
that's really.
you're right, the password. So maybe here's a way to do better authentication. Currently with the password, instead of looking at the keystrokes themselves, what you're looking at is the ASCII characters that result from it. This really makes very little sense. I mean, when people are comparing signatures, do they check the characters that you wrote? You know, this person signed the name Sethlong. Oh, we got a match. Okay, that's the right person. Yeah, that's not how they do it, right? So what you ought to look at is the scan codes, because then, depending on how fast you type your password, how long you hold certain keys down, which other buttons you decide to press, your password might be different. You can include a press with the caps lock key in your password. I think we need to design a new login system here. Anyway.
Some
Okay,
people
what's that?
have problems copying other people, especially those who type extremely fast.
Well, yeah, I mean, it would be sort of irritating because suppose you
You have to
were...
type it that fast every time.
Well, yeah, and so like if you got in a snowmobile accident and all your fingers were bandaged up, you couldn't log in anymore. But, you know, there's always disadvantages. I mean, you shouldn't get in a snowmobiling accident, right? I mean, that's just how it is. If you break all your fingers off under the snowmobile and you have frostbite and fall off, well, that's just bad luck to you.
I never really got the appeal of snowmobiling. It's like you're driving around in really high levels of snow in the cold. That just, I don't know.
I think it has to do with the conquering your fears thing. Like, people in the cars, they fear the snow. And so you hop in your snowmobile, and all of a sudden, you know, you're not just surviving, you're flying across a field of boogeymen, smashing them flat as you go.
Snowmobiling's
That's
awesome.
very poetic stuff.
I think of it like dirt biking without dirt.
I was on crutches for like 6 months from a snowmobile accident.
Oh, really?
Yeah.
Oh, that's funny.
Yeah, like every time I hear people talk about a snowmobiling trip they went on, they always mention something that just didn't go very well at all.
Well, it was my fault. I tried to jump like this little irrigation ditch, and that did not work
Yeah,
out very
that
well.
wouldn't go very well.
Okay, I typed the password, I pressed space, and I pushed the Windows buttons, because why not? This is all leading us towards Project 3, actually. And Project 3 is, I mean, the easy way to take care of it is just write the keylogger. And let's go talk about Project 3. It sounds like fun. Yeah, it really will be. It'll be more fun than the hiccups, guaranteed. Okay.
Stubbing your toe into the wall is fine in hiccups.
Well-
I only have once in a while. and they're
That's
very
debatable.
painful.
Yeah.
I'd rather just, I'd rather not take that second night.
Yeah, but it's only painful for like a couple seconds. The hiccups can last almost the whole day sometimes.
Okay, so this is the project description. This is
I don't mind
the wrong due date. I need to change that.
Usually see you
But you just track the last 15 characters, and this is probably not that hard to do, and analyze to see if they meet common password rules. So a lot of times there's these password rules. You know, it has to include certain symbols and things, and so it makes a password distinct in the feed from the keyboard. And so you just make a program that will, you know, to keep track of the past 15. And so the basic algorithm here is take the scan codes, figure out what letters they represent, which admittedly is a little bit of housekeeping here. You saw that you have to keep track whether the caps lock key is on or off, for example. And you have to see if they meet the common password rules. And you can incorporate time if you want to, because you know, usually you type the password and you're done. And so you can say, well, check the pass, you know, if the next character comes like way later, then it doesn't count. And so then you have some password candidates. So then you go ahead and make a file that gives you all the password candidates. And I should probably open this up in the web browser instead of the editor, just because it would nicer. Okay, so handling number one, like we've just been talking about, is the easy way to go. Did I remember to say that it has to be a kernel file and /proc? I don't see it on here, so I got to add that detail. I should have a file and /proc where the user goes and prints out the file, and they get the candidates from the password candidates. And so that's how the output comes back. Okay, and this is a little bit of verbiage update related to kernel 3.2 because we're using 3 point something else, but 3.14 or 13.
But you're going to write like a different description for if we want to do the other one too.
Yeah, I will. Yeah.
So if I looked up information on the internet about like writing a keylogger or stuff like that, would it be possible that I might get in trouble for that?
I doubt it. There's a number of keylogger descriptions on the internet, and when I was designing the project, I read through about 3 of them, and one of them I liked it quite a lot, and it looked like it was great, but it turned out that I couldn't seem to adapt it from the 2.4 Linux kernel to 3.2. Like, the kernel had fundamentally changed since the method, so I wasted like an entire day trying to adapt this silly thing, and it wouldn't adapt. But yeah, there's a number of projects out there, and if you decide to pick a completely different method and follow somebody else's tutorial and learn how to do it, that's actually fine too. And I think I need to include 2 bonuses here, like a 15% bonus for doing a USB keyboard. 15 is like 3%, which is worth a fairly substantial amount. I mean, that's like 30% of a regular project, or 10% bonus if you want to make your file system work on Linux instead. And as it happens, there's actually a tutorial on getting started on that. I went and looked at it once. I think it would be cool to do a demo in here where we actually do add a file system to Linux. That's the wrong one. That's not how to write one. Anyway, if you look around a little bit in Google, you actually find a tutorial on how to start writing your own file system for Linux.
Was it the one that was like file system in 30 days or something?
Yeah, something like that, yeah.
Okay.
Yeah.
Yeah, I've seen that.
Okay. Yeah, so that'd be a good plan too. And that one's definitely would take a little bit longer, but it would give you maybe a more interesting result at the end. So that's what Project 2 is going to be. So now you know, and you can start on it if you want to. But I'll get the official project description up probably tomorrow.
Would it have to be like an actual file system in Linux, or could we make it work with like a USB drive or something?
Well, it's got to be, you don't have to be able to boot Linux off it.
Okay.
You just have to be able to say, you know, mount-t myfs, and you know, wherever it is. And
so it has to be in like the FS drivers file then.
Yeah.
Okay.
Yeah, like Linux has to think it's a file system. It's okay if it actually stores all of its stuff in memory, Project 2 style.
Oh, so we can still use RAM, but Linux just has to think that it's a file system.
Exactly.
We don't actually have to write to the hard drive.
Correct.
Okay.
Right, because otherwise it's
Just
going
has
to
to
be a pain
see
in the
it
chest.
as a file system, it doesn't have to be physical.
Right.
Right, okay.
And there's lots of file systems that don't actually have anything on a hard drive, like SSHFS that I used to mount my software files here. That's just using the network interface.
So then would you want us to put everything resulting from that in proc then?
It probably doesn't need to have a proc entry.
Okay.
If you wanted one for debugging purposes to hold your debug log, it might actually save you some time because otherwise you're going to stuff dmessage full probably repeatedly. But it's I don't think that you have to have a proc file.
Okay.
There probably is a proc file describing the rest of the file systems, and yours will end up in it.
Okay.
But yeah.
I'm totally doing that.
Yeah, and I've never added a file system to Linux kernel. I feel like I should do some brief demo on it. I wrote a net file system for the NetBSD. I mean, you guys know that, so Linux can't be that much different, right?
So for project 3, we can pick either the keylogger or to mount a file system on Linux or on.
Exactly. Yeah.
Can we do both?
Sure.
Would we get extra credit if we did, or?
I
I don't know, I kind of want to do both, they kind of sound fun.
Does extra credit even make any sense at that point? Oh, sure, why not?
I mean, really, they both sound like fun projects.
Yeah, I'll
They
put,
really do.
I'll put some kind of definition in there for extra credit. I'm not sure if it should be extra credit precisely, or if it should be like, it replaces your lowest project score with 100% or what, but yeah, sure, I'll put some mechanism in there, why not?
But it bumps your lowest test score like 10
Right.
points or something.
It actually won't matter what I do. I mean, I could put in there that if you do that, you get an A for the class, because if you do both of that, you're probably going to ace my final, so, you know.
Yeah, do that, then we don't have to show up for the final. No.
What were projects 4 and 5 yet, I can't remember.
Well, 4 has usually been a memory leak finding project. And I've got a couple other ideas bouncing around in my head, so that's not guaranteed, but probably. Project 5 is making an advanced fork bomb that can actually be controlled. Normally a fork bomb just like takes down a machine, but this fork bomb needs to have a way so you can stop it. Because it's, I guess you could like hold a computer hostage with it or something. I think CryptoLocker is more efficient way to do that, but.
If I let go of the space bar.
Yeah, fork bomb where you can stop it later.
Make some ransomware.
Yeah, I guess this has an advantage over CryptoLocker that suppose you decided, and please don't do this, that you should be the only one who gets to use a Soptra because you want to use all 24 cores to do some kind of speed test on something. So you go ahead and start your advanced fork bomb on it, and everybody's like, Soptra is terrible today, and logs out, and then you stop your fork bomb and do your thing.
Sounds kind of fun, actually.
It sounds like fun unless you can't stop it and I have to walk down to the data center.
Just pretend nothing happened, I'm sure it won't get caught.
Yeah. Well, if you do it in the middle of the night and you thoroughly debugged it on one of these machines and I never know about it, then it's fine.
Just do it from Kyle's.
But it's worth negative extra credit if I find out.
So Project 4 would have been something like Valgrind where you actually looked for memory leaks then.
Last time what I did is I hid memory leaks in my implementation of the Project 2 file system, and then everybody had to find them.
Yeah.
And I thought they were kind of well hidden, but mostly they got found. So I need to do better next time.
It's because Valorant's awesome if you know how to use it.
Yeah, I think that was the usual way to find them.
Yeah, I actually remember in your tester.c file when I was trying to use Valgrind to make sure the rest of my file system that I wrote didn't have like any memory problems. There were a lot of memory problems that it kept reporting in.
Yeah, you have a lot of memory leaks in that file.
Just pointed it out. It was stuff like, I don't know, jump depends on uninitialized data or something like that.
Oh, that? Oh, I don't care about that.
You don't free a lot of the time.
Tester precincts.
No.
Technically after the program ends.
Maybe it was just mine, because there was like 5 left over, and it pointed to the tester. Yeah.
Leak summary, definitely lost 0, 0.
Huh.
Indirectly lost 0,
Yeah,
0.
that's an invalidated size 4 up there. I can't remember what all that means. But yeah.
Address is 0 by 0.
Still
Yeah, it's got a few gripes. That doesn't leak memory.
Oh no, you're right. Maybe
The
that's
difficulty
mine.
was that I couldn't see if there's anything wrong with my files. At least not very easily without going through the whole thing.
Yeah. The gripes there, part of what Valgrind is irritated by, and I sort of disagree with this on this. In a lot of cases, I'm using stuff of this form here. Ret is whatever comes back from F delete, and so it's pointing out that whatever ret gets assigned controls that jump, which is, I guess, not okay in its opinion.
So you're overwriting that, and it doesn't like that, basically.
I guess. I think it's fine. GCC can throw an error on here too. If you do like Wextra, maybe even Wall.
What are those two things?
And it turns on all the warnings.
Oh.
So it combines without warnings normally, but if you give it Wall and Wextra, it gives you all the warnings and then it gives you extra warnings.
Oh, cool.
And so if you turn on all warnings and extra warnings, it's got a lot to say about this program.
Yeah.
And so one of the things is suggest parentheses around assignment uses truth value. And you can, this is W parentheses is how you turn on and off that individual warning.
Oh.
And so it wants like an extra set of parentheses, which I think looks dorky, so I leave it off.
Yeah. So if you want to make sure your code is really, really, really good, you can just turn those two things on to make sure it doesn't pop
Yeah.
up any warnings.
Yeah, and it'll tell you things like warning, comparison between signed and unsigned integer expressions.
That sounds
which
like
is more
Xcode.
tinier.
Uh,
Yeah, it might be that Xcode is pulling Wextra flags.
That's
or
probably what it
something.
does. It's like you have to be like a certain standard for it to compile.
Well, maybe that's how Apple works.
Maybe Apple
Like-
standard.
Yeah, like maybe the Apple standard is if you haven't fixed all of your warnings, then you're not allowed to leave the premises until you do.
that sounds weird.
Steve Jobs clone comes up and holds you hostage.
Yeah,
Steve
yeah,
Jobs
exactly.
was kind of an asshole in real life.
Well, that would be a good reason for people to fix their warnings.
Probably.
That's right. He'll yell at you.
You get to meet the boss if you.
You don't want the boss to come down here. Fix your warnings.
Yeah. I need actual Mnet, but I think it's backed up on a soft drive.
Oh, but Gus, it's really no surprise that Apple forces their lifestyles and beliefs on everyone else, right?
It's true. That's why I refused to buy an iPad. They just refused to make it like a tablet.
I never saw the point of tablets. Why would I want one?
Well, not Apple's version of a
Portable
tablet.
Small TV.
I guess that's a good reason. I don't know, it just kind of seems large and bulky.
It's like a big iPhone. It's pointless.
Yeah.
Okay, this is a network
A lot of
monitor.
tablets for gaming.
And so this network monitor up here, it makes a file in /proc, and it counts interrupts. And so you can see it requests interrupt 48 on here. And 48, I believe, is going to be the network card, if I set this up right, because I'm pretty sure it used to work on this computer. That didn't do any good. I was hoping it would be like IRQ list, but I need to install stuff on here. Okay, let's go ahead and make this Mnet example and see what it does. Okay, so I want to make Mnet, and we want to insert it. Okay, .ko, there we go. So if we look at this thing real quick, it's got an interrupt handler that increments this variable count. And then we got this read int count here. And it's got a flop system here to print out stuff one time and then return a 0 like we have nothing more to say, so that you can just go cat the file and stuff will come out and then it won't. And you can see we're copying the number of interrupts that we counted to the user. Now, part of the reason of showing you this is to explain what CPUs do all day. Because they are, constantly pulled. I have a 2-year-old at home, and so right now I'm pretty sure that my wife is being presented with a constant stream of interrupts, because she always generates interrupts at within a particular frequency range. And so anyway, okay, let's go ahead and quit this thing and message. Okay, oh, that actually doesn't help anything. Proc Mnet. Okay. Well, we seem to have taught something out there. Let's take a look at this again. Okay. So there's a static size t there, count, and so what did I do wrong? I feel like it should give us something different. Like it shouldn't just be 2 to the 16th power. I'm always breaking these things somehow. This was actually the theme last time too, because I write these things and then I bring them up here and it wouldn't work. But anyway, so I got this proc entry and our interrupt handler, and we appear to be getting 65536. Let's RM mod it. So if we do that, it should be gone. Let's insmod it again and then try it right away. Now, we're connected remotely to that machine, so we're going to be getting a lot of these regardless. Oh, that's not what I meant. And I generated a stream of interrupts. 65536. Let's try something else. Let's try it on this machine where we're at right here. Maybe we got to get a chance at this. I want it to work. Okay, Satra. Let's see. Okay, I want to move to the Satra. I never remember the Satra password anyway. Almost there. Okay, so now we should be able to insert this thing in this machine right here. And I'm hoping it'll work on, this is an AMD machine, that's an Intel machine. We've got 2 different types in the room, but dramatically different. They have different chipsets and different motherboards and different everything. And so it might be that I try this one on this machine here. Okay. 65536. Well, that's irritating. I'm not sure what's wrong with this silly thing. It seems like the count here, it seems a little bit strange. The count would automatically go up there. And wait a minute, LD. No, that should be right. That's a long integer, like a size T. Unless it's not. Let's try D, just in case there's a printout bug here. Because I think that actually the answer may possibly, maybe or maybe not, be 0. Oh, and it's unsigned too. Maybe that's what we want. Oh, U. I bet you that's what we want. Okay. Oh, wait. Mod net. Yeah. It's mod. Okay. Okay, well, regardless, it's not picking these things up. My guess is the interrupt number is wrong. And there's not necessarily consistency here from one machine to the next, which interrupt the network card actually ends up on. So maybe it's just set to a different computer. Try one more thing. Okay. I don't have internet here. I think I deleted the copy that has the right interrupt number for this computer, probably. Sorry. Because remember, we overrode it with simple test. Unless I got a backup of it with something or something like a utility file. Oh, I got an old Mnet.ko. Oh, here's an idea. Oh no, we just made that, didn't we? That's too bad. So I overrode that one too. Well, I pretty thoroughly overrode the one that was set up for this computer. And I need to. So if we do LSPCI, we're going to see a number of different devices here. And it doesn't quite tell us which is on which one. Let's see if we can list the interrupts real quick and fix this thing. Okay. Probably not that one. But that might work. That actually sounds cooler than what I'm going for. There's a command that I can't remember right off the top of my head that lists what's using each interrupt. And it actually might be in /proc. So, you know, we could go, oh, proc interrupts. There you go. That'll work fine too. Okay, so here's interrupt users. And we want the network card. The sound card is 43, E0 is 44, that's our network card. 45 is the video card, FGLRX is the ATI driver here. This is the hard drive here, the SATA ones. The SATA_NV, my guess is we're looking at an NVIDIA chipset on this machine, even though it's got an ATI. The rest of this stuff. Yeah, NVIDIA chipset. I'd rather have an ATI chipset than an NVIDIA video card, but whatever. So that's what we're looking at right there. I mentioned this stuff is not necessarily, the USB interrupts are 22 and 23. That must be why the keyboard interrupt handler was set to one of those two. Okay, let's go real quick to that other machine we were looking at. R4C1, okay, there we go. Okay. So if we look at this one, where's the video card? Not a VU. Oh, this is an NVIDIA card on this one. Those are actually kind of cooler machines. The Intel ones are faster. So we got this test keyboard IR. Hey, there's our interrupt handler that we installed to monitor the keyboard. So we got the I-8042, that's going to be the handler for the regular keyboard, the normal keyboard interrupt handler. And we got our test keyboard IRQ handler installed, also handling interrupt 1. And you can see they're both on there, so that's fine. Some of these interrupts are shared for the USBs. I think there's more USB ports on these machines than there are on the other ones. But anyway, we're looking for the network card. That's number 48 there. See E0, 48. So if we want to monitor the network, okay. Then we're going to want, what was that a minute ago? Wasn't it 48?
48, yeah.
Oh. Well, we're monitoring the right one then. That's a little odd. We'll blow up the log file. Always good to blow up the log file once a day. Okay. Flags mismatch IRQ 48 versus, okay, so we're actually getting an error there. If we look at proc interrupts, 48, we don't appear to actually have this thing installed on here. Interesting. Let's go grab the machine we're sitting at. Okay. The voice is starting to die. It's okay, class almost over, voice is starting to die, we'll see which one wins first. This one it was like 44 or something, wasn't it? Let's check. Okay, so on this one, E0 is 44, yeah. Okay, that's not what I wanted. So, that's on. Okay, we got a couple of errors. Same flags mismatch. Okay, well apparently it doesn't work anymore. The kernel has had only a minor revision since last time this thing worked on here. So I'm a little surprised by that, but I'm not that surprised by that. I bet it'll work fine on other computers. I could try it on my, I can try it on my house computer. But yeah, I'll try to fix it later. My voice is out. Class is about done. Any questions? Okay. So this is why I say I don't know why the project is going to be hard, but something will go wrong. Because you've got all the pieces now. I mean, I showed you how to handle interruption with keyboard, right? You know how to make a file in /proc. You know how to write stuff to the user. And the password rules thing is just like simple coding stuff. You know how to set up timers if you want to, because the Blink one has a timer in it. So if you wanted to set a timer to invalidate or finish off your password after a certain delay, you can do that quite easily. Like let's process will set a timer, and then you can unset timers on there too. And that code's in the Blink there too. So you got everything you need to piece together Project 3. But these things usually have some kind of problem. So that's the only reason this twice as hard.
Well, I'm sure it'll be completely easy and finish in one night sort of project.
It might. It really might. I would not be that surprised if somebody was like, yeah, I finished the entire 20% project in 5 hours.
Project 1 in about 2 or 3 hours. That really just wasn't a hard project.
Yeah. In fact, I wouldn't even be that surprised if somebody finished this one in 2 or 3 hours. But I would be equally unsurprised if somebody was like, I've been banging my head against this project for a week.
So the file system, would we have to mount, would that also be like a kernel module itself? Or?
Yeah.
Okay.
Yeah, you have to be able to type mount, right?
Right. So when you mount, it has this -T option. And so for example, if you want to mount an ext3, you can do that. You don't have to use the -T because mount will auto-detect the type you mean by looking at the device you say next to mount. But in some cases, they work completely differently, like mount T CIFS. CIFS is like Common Internet File System, I think. It's the same thing as SNB, the Windows File Sharing Way. And so on my computer, I might have this command around. It's kind of enlightening. No, I don't. I can't get it back. Okay, well anyway, there's a file system on here that's probably not mounted anymore. That has, yeah, it's not, I'll have to figure that out again if I need it back. They used to share files around here. And so in order to mount it, what I have to do is like mount, type, common internet file system, and then I have to give it the location I want to mount. I think that's it. And then I have to give it some options. I don't remember what all the options are. But anyway, give it all that stuff. And then the kernel module associated, the mount will go and find the CIFS mount routine, and it'll use the kernel module for mounting SMB file systems or CIFS file systems, and make me a directory that has this thing mounted at it. Yeah.
Oh, so we have to write the mount method then to mount it? Or is that already in the kernel?
Well, mount is a program that's already around. You need to make the stuff that mount needs to take the type of file system and run with it.
So basically just like the ops for that, for
Yeah.
like what the file system has to do, and talk to the kernel with the like fs-h or fs.h then. So it knows it's a file system.
Yeah, you'll end up having to talk to the kernel with it, yes.
Okay.
And it's because it'll have to be built as a kernel module, and so mount, when it tries to do it, will tell the kernel we want to mount a CIFS file system, then we need the
Information.
yeah, we need the kernel module loaded. And then the kernel module should get loaded, or you can just insert it manually before you do it. But you should be able to say mount -t, I don't know, GusFS, and then you can, it'll appear there as more files.
KSFS, that is totally going to have that.
Yeah, there you go.
SUFS.
Mine's DFAT, distributed file allocation table.
Oh, that's right, yeah, I forgot that it already had a name.
I kind of like that name. I'm going with
Yeah.
that.
Not
Okay.
GusFat.
I googled it. There's no such thing, so now it's a thing.
Okay, cool.
So, yeah.
Yeah, sounds good.
Maybe SUFS will become famous and all be well known for, probably not, anyway.
These will all probably have really good performance being on RAM.
Russian bride.
What's that?
These will probably all have really good performance being in RAM instead of on the actual hard drive.
Yeah.
The only problem is it has to be a flat file system. I can't figure out how to add directories to it. But
Well, directories are just decorated file names.
oh, really? So like this file contains all the other files then? Is that how directories work?
Well, yeah, a directory is a file that has links to the other files.
Oh, okay.
So it's a special file, and then the file name is like the path to it.
Okay. Oh, so then I could work that in.
Yeah.
Okay, that'd be cool.
Supporting directories is optional since it wasn't in Project 2.
Okay. But if we get it to mount, then it should show up like in the GUI or something too. Like that's
Yeah.
just saved it there.
Yeah.
Oh, sweet.
Yeah, all the GUI does is show you what the file system tree looks like.
It's gonna be fun. Hey, so I guess since I would probably have to work on one of these computers for either project, because Brian had mentioned, I know, can't you like get on a list to be allowed to come into this room? Like,
You guys are on the list.
We all are on the list?
Yeah.
Oh, so I just have to go to the security office and say, hey, can I go up there? My name's on the list.
Yeah.
You need your student ID.
Right, because I used to do that for when I was working on the iOS app last fall.
Okay.
So I had to, okay, well, perfect. I'm
Yeah.
already on the list, don't worry about it.
Yeah, I put you all on the list.
Oh, thanks.
Yeah. No, Brian wanted to come in here, and I figured that other people might too.
Perfect. Oh, it sounds like a fun way to spend really late evenings in here by myself working on stuff.
Okay.
Is the
Maybe
building-
we could do that on the second floor if you've never, because like, I remember Ryan last year told me that that used to be a cadaver lab or something, so it's very sterile looking, and then you have the thought that there are a bunch of dead bodies all over the place around there.
That wasn't 240 though.
Well, yeah, that's what I mean. Yeah, on the second floor.
The cadaver lab was on the second floor, but it was like kitty corner to my office.
Oh,
That one.
huh.
Yeah, it wasn't 240.
I don't know. And it was actually around the time of the year that I started reading. To celebrate Halloween, I'll just go find creepy stories to read online.
It's like the other. It's like
Yeah,
the
it was
other
like the worst
corner.
combination. I'm in this building by myself, it's dark, and there's nobody else there, and
Yeah.
it's really, yeah.
Yeah.
Either that's the opening to a creepy story or the porn.
Well, you can demystify the whole corpses thing if you read this book called Stiff. Anybody here read it? It's actually really kind of entertaining and enlightening. And it's not really creepy. I mean, it talks about bodies and what happens to them, but it's fun.
Sounds kind of morbid.
Not really. It just talks about like how cadaver labs operate, and what sort of research they do on them, and all that kind of thing. And then like forensics labs, where they go lay them out in the field, and then they take the students, and they're like, "This is what a body looks like after 3 days," and they're like, "Ah!" And
Actually, well, I took anatomy and physiology a few years ago, and so I remember we dissected cats, because they didn't really look like cats, so I didn't care that badly. Oh, I never really looked at my cat the same way again. I just looked at the muscles, and I was like, yeah, hey, I know what this stuff is. And then they attack me because they don't like it when I touch their arms. Anyway, then we also looked at a human cadaver too, like right next to the classroom. It didn't really look like a human that much.
yeah, they're pretty disassembled when they're set up for display.
Oh, except when they folded one of the chest flaps over, and I saw a nipple, I was like, okay, that's a little too realistic. I'm done. That was kind of.
Yeah, I've seen those, and then for neuroscience class, we actually looked at brain segments and handled them.
Oh,
So you feel weird. They're preserved, so they feel different than they would in your head. Oh, but anyway, I guess that's all I got to say about this kind of stuff. And
Is that all?
so yeah.